So right now, no plan, people who don't know. Good evening, Saurabh. On Monday, I will announce. I didn't ask the timings. जल्दी आएगा जल्दी जाएगा भी रोहित. Oh, you are enjoying this, Aditya. So you don't know how the week is going. Okay, let's start. Okay, so let's start what we call synchronous counters. So we are discussing what? So now, good evening. What is your doubt? The clock is common for all the flip-flops in the Johnson and ring counters. You just check the previous lectures once, Magna. Good evening, Chaitanya and Sonam. So yesterday class we discussed yes. This part is completed yesterday. Okay, this is mod 8 synchronous up counter, and this I discussed this part yesterday class. Total delay is equal to this much. Suppose in this case, is it true? Remaining people, tell me. Any problem with the voice? Aditya, refresh. Please refresh, Aditya. Okay, very good. So these points already we have discussed yesterday class. So it will act as a mod 8. What is that? Up counter, all those things. So here one you can add one point. Instead of Q, if Q bar is given to AND gate, then same circuit will work like a down count. Okay, here triggering doesn't matter, only logic design is important. Even you don't remember this circuit also, no problem at all. Okay, now listen here. If you have one more, if you have, Udit, I told you yesterday also, okay, if you start analyzing from this side, you don't confuse. There is no rule you should analyze from this side only. You can analyze from this side also. But if you analyze from this side, once you change this value, you will be confused whether to take this as your input or this as your input. Okay, that confusion can occur. If you analyze from this side, now you are going first, you are taking the output, then you are taking this output. That is, after taking the output, you are changing the input here. So that's why it is better to do from this side. There is no rule you cannot do from this side like that. Okay, you can do from both the sides, but no confusion if you do from the right side. So what I am saying is here, if you want to make mod 16, what to do, sir? What to do is just to take one more flip flop, and from this output you connect to the next one. It will make it as a mod 16. Okay. In word, generally we don't analyze from the circuit. Okay, I will give you the method to analyze it. Don't worry. Just in the problems we'll do it. Okay. So like this, you can make mod 16 also. So let me make that also. Quickly, fastly, let's do this part also. So instead of 3 flip-flops, you will be taking 4 flip-flops. That's all. So clock will be common to all of them. Take all of them, any triggering, whether it is positive or negative, doesn't matter. It should be edge triggering. So here it is 1 1. And now from this point you should take one more AND gate and give it. Then this is J0, K0, FF0, Q0, Q0, J1, K1, Q1, Q1, J2, K2, Q2, Q2, J3, K3. This is the flip flop 3. Okay, so this is what we call mod 16 up count. What is this? Synchronous, because clock is common to all the flip flops. You see, the last remaining analysis it says when all the three, that is Q2, Q1, Q0, all are ones in the next clock pulse, it will toggle. Story repeats the same only. After this, if you have after 3 zeros, so please listen, after 3 ones, this will toggle means 8 will be counted. All these are zeros. So when 3 ones comes, next this will toggle and same story repeats. Okay, so now listen here. Here, your carry, that is your AND gate, is designed like this, the serial carry. See here, what we have done is like this. We took one AND gate for Q1, Q0. From the output, I took another AND gate and connected Q2. Then I get Q2, Q1, Q0. Here what I got? Q1, Q0. This is what we have done now. One AND gate, its output is connected to another AND gate. What is the disadvantage in this? Please tell me, what is the disadvantage in this? It is one gate delay, it is another gate delay, it will give you 2 gate delays. So the total delay TD is equal to TPD, that is the propagation delay of the flip-flop, plus 2 times gate delay. You can write this as TPD plus n minus 2 times TG, where n is equal to number of bits. Why n minus 2, sir? Listen, for first stage, no AND gate is there. For second stage, no AND gate is there. From third state, fourth state, fifth state onwards, you will be getting one AND gate. You can also do this like this, what we call parallel carry. Here, you take 3 input AND gate instead of 2 input AND gate, which is better. That is Q1, Q0, you take it here. And separately you take parallelly this also. That is, because of this, what is the advantage, sir? It is requiring only one delay. That is, from here, don't take it. You take from here and connect to 3 input AND gate. So in this case, your total delay will be equal to TPD plus 1 TG only. It is not depending on N at all. So generally, your time period of the clock should be greater than or equal to TPD plus, you can say like this, TD plus T setup. Do you remember setup time? Setup time is the time required to get the, time by which the input must be present ahead of clock. Input तैयार करने के लिए time चाहिए, that is called as setup time. Before applying the clock itself, this is coming. After applying clock, this delay is required to get the output. So total time period should be more than this one. Yes, this is before clock part and this is after clock part. TPD and TG. Okay. So then before next clock, these three things, setup time and this one should be completed. So your time period of the clock should be greater than TD. TD is what? TPD plus T gate plus T setup. So the frequency of the clock should be less than or equal to 1 by TPD plus T gate plus T setup. Now the frequency maximum in the synchronous counter is 1 by TPD plus 1 by T gate plus 1 by T setup, which will be equal to 1 by TPD plus T setup if T gate not given. If examiner has not given this, you neglect it because it is not in your hand. Sometimes you can write it as 1 by TPD also. If T setup not given. Generally in your gate exam, abhi tak they have not given setup time. So people will neglect. Directly they used to use this formula only. Earlier also I gave the same formula. In 2020 they have given the question based on the setup. TPD, what is TPG? Gate and see here, gate is to give the input, flip-flop is to get the output. Both are working parallelly. Okay, you see here, instead of this and gate, only gate will change. Then flip-flop will work. Before clock means this is your clock, man. It's a continuous. You tell me here you applied the flip-flop data, so whatever you call, you have applied this at this point of time. You have applied the clock. It requires a TPD. Okay. Then you require little more time. What is that? For setup of the next input. Yes or no? So this is the minimum time you should wait before getting the next clock pulse. After TPD, you may get your output. But for next input, you should wait for setup time. Okay. So in general, for asynchronous, it is NTPD. Synchronous, it is only 1 TPD. So synchronous faster than asynchronous by n times, almost, approximately, because it is not originally TPD. Some extra points are there, setup and all. Okay, so that is you are able to prove that it is faster and no transient state, so you can have. So that's why we prefer synchronous in the design. Okay. So it requires extra gates. So one advantage is there, definitely one disadvantage will be there. Speed improved, hardware may be more required. Earlier you don't require these gates. So you have one advantage, definitely something you will be sacrificing. Please understand that. So let's move. Okay. Now let's see how to design any counter with any flip-flop. Let's have black theme. Which one you like? Dark or white? Color, dark screen giant. Okay. Next slide says dark screen. There are no dark please. Shall we have poll for this? A for dark, B for white, C for कोई भी चलता. Both are same. इसमें right answer D. 18 नहीं, इसको 36 आया, इसको 34. Is good on dark design synchronous. It is 0. Help of D flip flop and any random sequence. How to do the count? Let us see. So see here your answer. What is the number of states? 1, 2, 3, 4. So it is a mod 4 counter. Log to the base to 4 is equal to 2 flip flops chahiye. After that, this is the standard process to do it. That is, you should make one table. That table entries are, first one is present state. What are the inputs you want to give? That is DB or D1, D0. D flip flop na. Present state is Q1, Q0. 3, 1. What do you want to design? Okay, so this is the what are the input? What are the input? We should fill this with the excitation table. Same as excitation table only. So start with all zeros. Next 1, 2. You are designing this. Please understand. 2, 3. Okay. So next state. Next what you want according to the question. 0 ka next kya chahiye? 3. 0 ka next you want 3. Similarly 1 ka next what do you want? 2. 2 ka next what do you want? 0. And 3 ka next what do you want? 1. Up to this clear how to fill the table? This is according to the question of the examiner. You want to make this sequence using which flip-flops? D flip-flops. So now D1, D0. What are D1, D1, D0? Excitation table of the D flip-flop, very simple. Qn plus 1 equal to D. Using that rule, what you want is, okay, in the next state, same should be given as the input. D flip-flop excitation table is very simple, same as whatever you want here, same should be given here. That's all. It does not depend on the present state. So now what is D1? It is 1 for 2 cases. It is 1 for 2 cases. D0 is 1 for 2 cases. So what is your D1? What is your D1 is? It is 1 for this case and this case. That is Q1 bar, Q0 bar plus Q1 bar, Q0. Q1 bar. What is D0? It is 1 for here and here. That is Q1 bar, Q0 bar plus Q1. Then it is equal to Q1 XOR with Q0 whole bar. Okay, your job very simple. So take 2 D flip flops. Okay, triggering can be anything. It is your choice. Nothing. There is no, no difference based on the triggering of the flip flop here. Okay. So now, whenever, what is your D1? It is a Q1 bar. Next, what about your D0? It is a XNOR operation of Q0 and Q. Ruchita, that is for asynchronous. For synchronous, clock is common for both the flip-flops. So take 1x. 1 minute, I'm sorry. D1 equal to Q1 bar. Yes, I'm sorry. Why? 1 minute. Here, that rule is not applicable. Clock is applied to only LSB. That is for asynchronous only. You can take XOR also by taking one of the input as complement. You know it. So Deep, what is your doubt? We need to count last 0 as the last state in the question. What is your doubt? This is a cyclic operation, man. After 2, you should go back to 0. Okay. After 2, you should go back to 0. Number of states, you count here 1, 2, 3, 4. How many different states are there? 4, 4. Triggering can be anything as per your wish. Anything, any other question? 2 can extend 0, le liya na? After 2, it will come back to 0. Make this cyclic table and do the design accordingly. Kya problem aama? Firstly, keep your mind outside of the asynchronous. Asynchronous may you apply clock only to one flip-flop. Synchronous may you apply clock to both the flip-flops. Then what to do? How to design it? You should make this table present state. This is the, here you should take all combinations 0, 1, 2, 3. How many combinations possible? All you take here. Next is how to write it according to the table given by examiner. Table given by examiner will say 0 connect state 3, 3 connect state 1, 1 connect state 2, 2 connect state 0. Simple. So 0 connect state is 3. 1 connect state is according to this equation. 1 connect state kya? 2. 2 connect state is 0. 3 connect state is 1. What is there in it? Tell me now what is the doubt? You can keep according to your wish. Equation should be satisfied. That's all, Aditya. I didn't get you, Rohit. SAR clock asynchronous में LSB पर clock apply करते, right? That is for asynchronous. For synchronous, you apply clock to all flip flops at a time. Wherever you apply the clock in the asynchronous, that is your what we call LSB. You want to? Shall I show you the asynchronous figure again? Let me show you for your क्या हुआ लास्ट लेक्चर का क्लास है हमारा पास हाई looks like that. Okay, this is for asynchronous. You observe. Listen here. This is your asynchronous. Okay, clock applied only here. This is clock to this, this is clock to this. Okay, in this no doubt now. Here you apply clock to both of them. Here don't worry about which one is LSB, which one is MSB. That is according to here D1 may be MSB, D2, D0 is LSB. You draw it reverse also, no problem. D1 should get Q1 bar, D0 should get exclusive NOR operation of Q1, Q0. That's all. Here, okay. Now in this any doubt, please ask. Copy 1 minute. Sushil is having any doubt. Yes, Bhargavi, correct. See here, triggering is not having any job. Triggering will change your output either at the positive edge or negative edge, but change happens according to the excitation table. That is according to your inputs. Here your input is not clock. Here the flip-flop is not in the toggle mode. Flip-flop is not in the toggle mode. It will not worry about your triggering here. Your design is for any triggering, but this change can happen at the positive or negative edge according to your triggering. That's all. Triggering will give you when to change the output, but not how to change the output. No concept here. Those concepts are only for asynchronous. Where is right shift register here, Aditya? I don't know what you are asking. Where is right shift register here? Here there is no register at all. This is clock which is common to both of them. What is your problem in that? Please ask it clearly, Aditya. See here, synchronous clock, whether you give it like this or like this doesn't matter. Synchronous, both you are giving at a time. What is your doubt in that? Wherever you apply, it is same na. It is synchronous. All of them together you apply. You apply here. Keep your way here. What is the difference? Both of them together we apply it. Okay. In right shift, left shift register, we show like this to represent it, whether it is going this side or this side. Okay. This may be shown like that, but you are giving to the clock input, which is common. That's all. Okay. So shall we move further? Any other doubt, please ask. Design few more circuits. This is the process of the design. What is the process of the design? This is the present state. What is the next state? According to the question, according to your requirement, then what are the inputs to be gone? So you understand the process, how this process comes. Listen here. You are designing a circuit here such that when present input is this, present state is this, you are designing a circuit to get this in the next. To get this in the next, you should design such that these two inputs will go to the flip-flops. Similarly, presently this is your state. To get next this one, you should design your circuit to get these two in the next. This is what happens every time. Okay, this is the meaning of the design. So let's do the same thing with T flip-flops and one more question. Design here. Next question. Design a synchronous counter to count the sequence 03560 using T flip-flops. Okay, next, and check whether it is self-starting or not. Okay, so this is the question. Firstly, here one line is there. What is that? Self-starting. Let me give you that explanation first before going with it. In synchronous design, if the counter enter into any unused states, if the counter coming back to used states on its own, then it is self-starting. If it is rotating in unused states only, then it is called lockout problem. When lockout occurs, counter is called non-self-starting. Okay, next line. I will explain it, just wait. When lockout occurs, we need to restart the system or redesign by taking next state of all unused inputs to any of the used inputs. I will explain these points with the help of this problem. Just for time being, leave it. Now, let me design this counter. Let me give you some different. Okay, so let me design this flip-flop 0, 1, 2, 4, 5, 6. This is the counter I want to design. So what is this? Mod 6. What is the number of flip-flops you want to take? 3 flip-flops. Okay, so now let's design this. So what is the state? What is the sequence? 0, 1, 2, 4, 5, 6, and again 0. So here, what is the present state? So here, present state. What is the next state? Same process. Then what are the inputs to be applied? So inputs are here T flip-flop. Here present state Q2, Q1, Q0. Here Q2, Q1, Q0. So here all zeros to all ones we should take. Okay. So here you should have, listen here. Here this is the circuit, right? So 0, 1, 2, 4, 5, 6. So what are the next states? 0 connect state is 1. 1 connect state 2. 2 connect state 4. 4. 3 connect state is not there. Take don't care. 3 is not there, not don't care. Next 4. 5. 5. 6. 6 connect state is 0. Again 7 is not used. Don't care. So T2, T1, T0 is, T flip-flop character excitation table. Qn equal to Qn plus 1, your T must be 0. Qn not equal to Qn plus 1, T must be equal to 1. You remember this or not? If they are different, you should give 1, otherwise you should give 0. You tell me here 0, 0. You just see Q2 only. This is 0, this is 0. Same means give 0. Same means give 0. Here Q0 and Q0 are different now, so you should give 1. So same means you should give 0. Different you should give 1. Different you should give 1. Different give 1. Different give 1. Same you should give 0. Then this is a don't care condition. Again, same means 0. Same means 0. Different means 1. Here same means 0. Different means 1. Different 1. Same 0. This is don't care. Everybody understand this? Up to this, any doubt, please ask. Otherwise, we'll move forward. Now, what you need to do is you should make 3 K-maps. Very good. So this is Q2, Q1, Q0. So Q2, Q1, Q0. Zero, 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 1, 1, 0. Okay, fine. So what are the inputs you should write is this is for T1, sorry, T2, T1 and T0. Okay, so you should fill corresponding. What is the corresponding one? It is 0, 0, 1 cross and 0, 0, 1 cross. Here 0, 1, 1 cross and 0, 1, 1 cross. Lastly, double 1, 0 cross, double 1, 0 cross. हो गया आपका job. So now this is one quad. This is another quad. 0, double 1 cross. T1 is wrong. 0, 1, 1 cross. 0, 1, 1 cross. I don't know. Which can be. 1 minute. Let me check it again. 0, 1, 1, 2, 2, 4, 3, 7, 2, 6. Okay, so let's do it, no problem. You can take this as one quad, this as one quad. I have not, no problem. So what is your T2? This is not, what is the T2? Q1. What is T1? This is Q0 and Q1. And what is T0? Q1. You can draw the circuit now. Taking 3 flip-flops. Okay, clock common. If you want, I will draw it. What is there? 1 minute, please. Okay. So this is the what we have designed just now. Next. So if you want to draw the figure, I can draw. You take 3 flip-flops. You take any triggering. I already told. Okay, take the clock common. Okay. So this is a T2, T1, T0. You take any order, it doesn't matter. Accordingly, you should make the inputs. That's all. Okay. Now what is that? See here. For T2, it is a Q1. So take one line from Q1 and connect it here. Next. For T1, Q1 plus Q0. What is that? Q1 plus Q0. Take one OR gate. Next. For T0, it is Q1 bar. That's. Is it clear now? Just make the figure according to the equation. That will finish your job. Now in the question, what is the point I told? Whether it is self-starting or not. Okay, don't worry about your delays. Okay, here, yeah, only one gate delay, same only. Aditya, now see here, what we call self-starting or not. Let us check it. What is self-starting? Okay, here, what to do for self-starting is, so whether it is self-starting or not, how to check it is take unused states. This is what we call analysis. Here, what is this? Design. Just a small difference between design and analysis is when you are designing the table is the present, next, and input. For analysis, what is the process is present state. What are the inputs? What is the next state? Table will change. What is how it will change? Present state. What are the inputs of your design? That is T2, T1, T0. Okay, Q2, Q1, Q0, and what will be the next state? That is again Q2, Q1, Q0. So T2 is how much according to the design? Q1. Okay. Just don't ask any doubt until the completion of this. T1 is, then all your doubts will be automatically cleared. Just wait or hold. Then T0 is what? Q1 bar. Okay. Right. Sushil. So here you should take the unused states. What are the unused states in your design? 3 and 7. For 3 and 7, according to these equations, what is Q1? 1. What is Q1 plus Q0? 1. What is Q1 bar? 0, 0. So according to this design, if 3 occurs by chance if 3 occurs, these are the inputs will go. And if you apply the clock in the next state, what is the output you will get? It is for 1, it is a toggle. For 1, it is a toggle. Okay, then what is this? For 0, it is no change. No change means what? 1 only. Next, similarly, for 1, it is a toggle. For 0, no change. So now, listen here. You have designed a counter to count this 0, 1, 2, 4, 5, and 6. This is what you are expecting. Okay, these are called as state transition diagram of used states. Okay, now if unused state occurs, what is the unused state? 3, by chance if it occurs, where it will go? If by chance 3 occurs, the next state will be 5. If by chance 7 occurs, what is the next state? 1. This is what we call what? Self-starting counter. Why it is called self-starting, sir? I will give you the points now. Let's see. 1 minute. My dear, 1 minute. Just go through the points. In the synchronous design, if the counter enters into any one of the unused states, okay, if counter is coming back to the used states on its own, okay, without your job, without doing anything from your side, then it is called self-starting. Up to this line, it is sufficient now. Okay, up to this line, it is sufficient. One minute. Okay. So what is your doubt, Sushil? It is a T flip-flop. T flip-flop, please see. If your input is 1, what is the next state in the T flip-flop? For T flip-flop 2, okay, present state is 0. Your input is 1. What is the next state? Toggle. Toggle means it will become 1. Similarly, for T flip-flop, present state is 1. Your input is 1. Toggle means it will become 0. So present state is 1. Your input is 0. Input 0 means it will be in the previous state only. Okay, here what you are seeing is only truth table. Excitation table is when you need inputs. Here you don't need inputs. Inputs are ready. You are reading outputs. So two tables are there. Listen here. This is just a truth table only. See the truth table of the flip-flop, you will get it. This is for analysis. This is for design. Design is present state, next state input, that is your excitation table. Analysis is present state, already you have designed. Okay, so you take that design, you just analyze what are the outputs you are getting. That is analysis. Yes. Okay. So these are the points I give. According to this, it is coming back on its own. Okay, you are not doing anything. By chance, if some noise take it to 3, it will come back to your 5 and it will rotate again in the user states. No problem. So let's take one example where there is chance of lockout problem. Okay, let me take this one more example. Design a sync counter. Sync means synchronous. That's what I'm discussing. Just wait for some time, Lucky. Okay, design a synchronous counter which counts 0, 3, 5, 6 using the T flip-flop. Actually, it is a mod for counter only. You can do it with 2 flip-flop, but I am taking maximum count 6 plus 1 log. That is the 3 flip-flops I'm taking and do. Okay. Wait, Pupul, I will explain, don't worry. So if you design this with the 2 flip-flops, there is no chance of lockout problem. But what is the disadvantage? You need extra converter circuit. In this particular case, for example, you can do it with 2 flip-flops also. Suppose you made it with 2 flip-flops, 3 flip-flops. Pupul, I will explain it again in this case also, so don't worry. So what is the design you need to make here? The previous one is as it is, okay. I made a small copy here. Zero, 3, 5, 6 and 0. This is the design you need to make. Here small differences are there. What are the differences? Let's make it accordingly. So 0 is there. These next states are not same. Here you should. We should fill this. No, what I did is here I made this as image and here I used the original. Image cannot be erased. Because of that I did this. One minute. Small. Yes, Aditya, provided you know how to use it. Everybody is using this screenshot facility. So we are ahead of them. Okay, so let's do it. Okay. So listen here, 0 next state is according to this question, it is a 3. 1 is not given, 2 is not given here, 3 next state is 5, 4 next state is not given, 5 next state is 6, 6 next state not given, so 6 state next state given. Aditya, we are logical, not advanced, but we are logical because we are teaching logic design. So here, this part is don't care. Let me fill it first. Remaining. So 0, 1, 1. Same input should be present next same ITO. You should take 0. Different means, okay, you should give 1. This is what? Excitation table. Because you are designing here, you are only designing this. Okay. So present and next 0 and 1 are different. 1 and 0 are different. 1 and 1 are same. Very good. 1 and 1 are same. 0, 1 different. 1, 0 different. 1, 1, 0, 0. Both the same, it is 0. Just same as previous question. Now 0 double cross 1. Okay. Cross 1, 0 cross. Is this? 0 double cross 1. Cross 0, 1 cross. I'm sorry. Cross 0, 1 cross. Next. 1 double cross 1. Next. 1 double cross 1. Cross 1, 1 cross. Next. 1 double cross 0. Cross 1, 0 cross. So here one rectangle, it's a quad, it's a rectangle. So rectangle, I'm sorry, quad, octet, quad. So what is your T2? Is Q1. Here T1 is 1 and T0 is Q1 bar. Okay, Q1 1, Q1 bar. You can draw the figure now. Okay, so now let's analyze whether it is self-starting or not. I like number 3. That's why. Krishna, I already told that condition, Rohit, at that time what you people are doing. Remaining people, please tell me I have done it or I already told it or not. You can do with 2 flip-flops also, but you require converter. So in this case, I am trying with 3 flip-flop. Both are possible. Yes. Because converter is required, we are going by this, trying with 3. Okay, we should check self-starting. Now, some people earlier don't understand this. So let me give you unused states. Let me analyze unused states. Analysis. Now, the people you don't understand the previous one, now you can understand. Please see. Here you should take present state. Okay, what are the inputs according to design? This is already made. Q2, Q1, Q0. And next state. Q2, Q1, Q0. This is Qn, Qn plus 1. Now T2 is Q1. P1 is 1. P0 is Q. Yes. Listen here. Just we are doing analysis. Already job is done. You are just analyzing it. There is no need of any excitation table here. So take all unused states. What are the unused states we are having in this question? 1 is not used, 2 is not used, 4 is not used, 7 is not used. All of them are unused. Then what is Q1? 0, 1, 0, 1. This is 1. What is Q1 bar? 0, 1, 0. I'm wrong. Q1 bar will be 1, 0, 1, 0. Now, let me make it different colors. 0 1 0 1. Now up to this, is it clear, people? Now what you need to say is just take it as a truth table input. If this is present state, this is the input. What is the next state? Simple. So this is the input 0. So output same as previous value for Q2. Okay, for T2 and Q2. For T1, what is the input? 1. That is a bar. For T0, it is 1. So previous bar. Similarly, if it is 1, previous bar. If it is 0, same as previous. If it is 0, same as previous. If it is 1, previous bar. If it is 1, take the previous bar, and if it is 0, take this as it is. This is how you can make it. Now, see here. Your used states are 4. What are they? 0, 3, 5, 6. Okay, these are what? Used states. Now, let's do unused states. Unused states are also making 2. Sorry, 1 is there. First state is 1. Then what is the next state of 1? 2. According to unused states. If 2 is there, what is the next state? 2 next state is 4. What is the 4 next state? 7. 7 next state. So unused states has made a loop. This is what we call lockout problem. If by chance the counter enters into any one of the unused states, then counter cannot come back to the used states. It will be rotating in the unused states only. This is what we call lockout problem. When lockout occurs, we need to restart the system such that it will start from origin or used state, or redesign by taking the next state of all unused to any one of the used. Okay, why this is happening? What is the reason behind this? Let us analyze a little. Now, up to this, everybody clear or not? Please tell me. You are able to understand? You have doubt? Ask. Okay, why poll here? Any doubt? You ask your own. Never ask poll for your doubts. Okay, my class, I give full freedom to ask your doubts. When lockout occurs, it is not self-starting. Any individual have any doubt, please ask. I am happy to help you. If you want poll, I will conduct poll for one question now. Don't worry. How to recover from lockout, I will tell you. Just wait. Ganguly, lockout means this is the loop you want. But counter by chance jump into this. Then it is making loop of unused states. It is rotating in its unused states and not coming to the used states. Because it is not coming to the used states, it is called a lockout. It lock kiya isme. It is locked in the unused states. It is locked in the unused states. Only we have one unused. Then also, okay, one unused state is only there. One is the only unused state. We don't know, it may form loop with itself. Here, our how to check lockout means whether it is coming back to your white part, that is used states. 7 ka next state or 3 ka next state, whatever may be, whether it is able to come back or not is the what we call non-lockout. Okay, here self-starting on its own it is coming back. Even one state left, then also it can form a loop. You should check. We cannot say that. There can be situation. Wait, Aman, one by one I can answer. I cannot answer two questions at a time. Your doubt is there only. Don't worry about it. So there can be a situation when one unused state can come, then after it come to unused state. But you are saying like this: 1 connect state to 2, 2 connect state is 5. Okay, this is no problem. By chance it enters here. Finally, it is coming now, self-starting on. Good. So Aman is gone. I mean, Aman doubt is gone. Vasishta, sir, for writing the next state table is same process followed by other. Any flip flop, same process. Design and analysis, same process. Why here loop is formed? That you should ask this design. Because of this design, it happened. Why that is happened, I will explain. Your doubt is clear without explanation. Amitabh, very good. If unused comes back to used, then it is self-starting. That's what I said. Yes, Nishita. If by chance it come back to like this one line is there, it is self-starting only. Okay, I mean from 7 there is no loop. Like this, finally it is coming, definitely self-starting. How can you get that condition, Udit? If it is not, loop will be definitely formed. At least self loop should be formed. Without that, can it be isolated? You have 1, 2, 4, 7. Can you show me 1 should have any one of these states, 2 should have any one of them, 4. Finally, it should come here or go to any one of them. If it go to any one of them, it will form a loop definitely. Udit, when lockout occurs, definitely loop will form, whether it may be self loop also. So now, please listen, everybody. Okay, all your doubts are clear? Anyone else? Unused को used state से के साथ क्या करेगा? Okay, listen here. See here, in the previous question, why this unused state occurs? Tell me. Why this unused state occurs? I mean, why this lockout occurs? Ah, very good, very good. Okay, unused may enter into because of some disturbance, but why this lockout is occurring is because you don't care here. Here you don't care, because of that system is don't caring you. Here if you take some care, system will care of lockout. अभी आपको गेट को केयर करना चाहिए, फिर गेट will take care of you. You take care of the subject, subject will take care of. So same here, you don't care here, so system will take the revenge. So now listen, one reverse analysis I will tell you, you may not be seeing in your books also. So let me do some reverse analysis for your better understanding. Okay, Abhinit, just hold your doubts. I will clear all your doubts. Those points are already in my mind. I will explain. Okay, so all your doubts will be cleared. Let me explain first. Up to that point, it is clear now. Remaining, just wait. So now see here. Originally, this table may, if you don't take it as don't care. No, sir, I care it. How I care is it? It should not be don't care, sir. It should be either 3 or 5 or 6 or 0. Then I can be happy. Okay, this point you understand or not? First, tell me. Here it should not be don't care, sir. It should be 3, 6, 4. I mean 3 or 5 or 6. Then no problem for me. It should not be don't care. Then you will get one doubt. I will ask you with a poll here. Is it required? First point. Is it required to take next state of all unused to any of the used, or is it enough if we take, don't comment, I will conduct the poll. If we take one unused next as used. Yes or no? Yes means one is sufficient. No means you should take all. Question I will repeat clearly, just listen. I will conduct the poll, just listen. Is it required to take next state of all unused? Is it really required to take next state of all these unused to be taken as any one of the used? Or you design like you leave all of them, take any one of the unused, but take here as one of the used. Is it sufficient? That is the question. Is it clear, my question? I'll start the poll because you love the poll. Question is not clear. Is it required to take the next state of all unused states to any one of the used to avoid lockout? To avoid lockout, is it required to take the next state of all unused to any one of the used, or is it enough to take only one unused state as used? I am asking here, the design is there na? Is it really required to take the next state of all of them like this, or I am asking, is it enough if you take, you may leave 3, you may take only 1 like this? Is it clear what I am saying? You have 4 don't cares in this na? Will you leave all, will you take care of all the 4 don't cares? Don't comment, Saurav. I told it will be a poll. Okay, is it required to take, okay, don't cares of all these don't cares to any one of the used, or is it enough if you take one of them? Okay, so if you say yes, you are saying that one is enough. Okay, you say no means all are required. If it is yes, what does it mean? One is enough, sir. One I should take care. Okay. No means what is that? All should be taken care. So start the poll, yes or no. Yes means only one sufficient. No means we should take care of all of them. %77% wrong answers. 77% wrong answer. You should take care of all. You should take care of all. Winner name I don't know, only percentage will come. Okay, you don't know. Suppose you may have the doubt, sir. I just take this next state as a 3 and I remove this, sir. I mean, for 7, I design like next state 3, remaining I neglected. You are not sure. There may be a chance these 3 may form a loop now. Okay, or you don't know, only 2 may form a loop with it. So you cannot say that. So what we can say, you should take care of all of them. Here I told it already. When lockout occurs, we need to restart the system or redesign by taking the next state of all unused inputs to any one of the used inputs. Right, Mohan? Okay, now come back. Little reverse analysis I will show you. You may not done earlier. So listen here. This is not part of the question, but for understanding the problem, you see here. You have don't care here now. Reverse analysis I am doing. Don't care means when it is in the box, it is means 1. You are treating this as what? 1. When this is in the box, you are treating it as 1. You are treating this don't case as 1. Okay. So this is only now filled here. So which are taken as ones, which are neglected are zeros. You accept it or not? Which are neglected are treated as zeros, which are considered are treated as ones. So now please listen. Neglected is, for example, for T2. For T2, what are neglected? 1 is neglected, and 2, 3 are considered as ones. 1 minute. 2, 3. Okay, in the 2 is considered, 3 is already 1. Again, 4 is neglected. 5, 6, again 7 is considered as 1. You accept this or not? You understand this? From this table, 2 and 7. 2 and 7 are made equal to 1. 2 and 7 are made equal to 1. Remaining I made equal to zeros. Similarly here, all are considered as ones. All are considered as ones. Here, 1 and 4 are considered as ones. 1 and 4 are considered as ones. Remaining are considered as zeros. Okay, now see here. Now see here. Do the reverse analysis. So if you apply this 0, 1, 1, this is your present state, na 0, 0, 1. You apply this input. What is this input? 0, 1, 1. Okay, what is the next state? For 0, present state, 0 is the input originally because of this treatment, then it is no change. For 1, 1, it will be toggle. 1 means toggle. Similarly here, if you have 1, 1, 0, okay, this is 0, 1, 0, na? This is 0, 1, 0. So you understand here, 1 means toggle, 0 means as it is. Here, what is this? It is a 0, 1, 1. 0, 1, 1 means 0 means as it is, 1, 1 means toggle. Here also 1, 1, 0. 1, 1 means toggle, 0 means as it is. From this also you can directly say your design is saying that for 1 next state is 2, 4 next state is what is 2 next state is 4, 4 next state is 7, 7 next state is what is this for 0 it is as it is 1. You understand? This is your design, your own hand design only made this possible. Because of your design issue only this lockout has occurred. It is proved because how you treated the don't case will decide your lockout problem. Everybody understand this reverse analysis? So now you got the clear picture how to understand your this one what we call lockout problem, why this is occurring in your design. So what is the meaning of don't cares and all? Yes, if please already these ones are ones only, these zeros are zeros only. Okay, how you treated don't cares in your design? When it is in the box, it is 1. When it is neglected, it is 0. If you don't use the don't care, it is treated as 0. Here the process is whether you treat it or not. Here the process is this should not come here. This should be any used. Then only your design is happy. So while designing, you can cross check like this also. Okay, this is what we call reverse analysis. If you don't understand this also, not a big issue. But you can understand better. I mean, what's happening internally, what is the meaning of the don't care, etc. You can understand properly. What is your ASIP doubt? Sir, if you design only with ones and don't take, don't care, then lockout problem occurs. No, please listen, it will occur. You design with one also, indirectly you are treating them as zeros now. Indirectly you are treating them as zeros. In that case, you are treating all of them as zeros. Then if one comes, then most compulsory occurs because you get 0, 0, 1. Self loop can be formed in that case. It is more dangerous. You are giving 100% chance for the lockout. Okay, that is for T flip-flop, you can say, not every flip-flop. So in digital, your analysis, your common sense plays more role than how much I explain. All your doubts can be analyzed on your own. If this happens, what is this, everything you can try. Okay, right. So that is about your lockout problem. So let's have one more problem. Sequential slides. Just 1 minute, small issue is there. One UO means what here? Rohit, please ask clearly. Where is the sequential part? Listen here. 1 minute. Let me get the question. Next question. So, in real life, manufacturer face this issue. Yes. We should avoid these lockout problems. In any design, you should avoid this. Anyone explain what is the advantage by taking one? There is no advantage. Who said that? Have I ever said that one is advantageous? What is your doubt, Rohit? Ask me clearly. Why I have taken here one is your doubt because you have considered in the K-map. K-map mein in the quad you bubbled it na. Bubbled it means you are considering it as one. Why you have taken this as one? Because to minimization of your equation. If you don't take this whole octet, then what you get to XOR gate will come. Because of this octet, you are getting one. So when in the SOP expression, if you consider in the quad, it is 1. If you neglect in the quad or pair, then it is 0. This is the K-map basic. Okay, I have not accidentally taken this as 1. It is in your design, it is there. According to your design, this quad contains whatever inside this quad are 1 for you. Outside the quad are zeros for you. Okay, because of that only we took these two ones here. If it is not neglected, we took zeros here. We analyzed this here. I told reverse analysis from here to here, here to here, here to here. I already answered Harsh. You are in the class or not? Same question is asked by Deep already. Not Deep. Who is that? Asif. Asif asked me, if I neglect the don't care, what is the answer, sir? Okay, I already told that. If you neglect the don't care also, you are treating it as a 0 only. So 0 is not avoiding the don't care. Here, next state should be used state. That is our requirement. If it is 0, 0, 0 here, you neglected the don't care, 0, 0, 0 will come. 0, 0, 0 means the same as the previous value. This is more dangerous. So here, how to come back out of this don't care is take here any used state. That is the only answer for us. This K-map basic you should have mind. Everybody, is it clear? This is coming from the K-map. This is your design. According to design, don't cares are ones for this, zeros for this. And fill this and find this. Okay, right. Now let's do this question. Okay, first question, first find mod. Find the mod of this counter. Will the counter lockout if happens to be is means where is there any lockout occurs? Find the maximum rate at which the counter operates satisfactorily. Assume the propagation delay of the flip flop and AND gates are TF and TA respectively. So if you are okay, I can start the question. Yes, very good, Rahul. Good observation. It is a question with both, that is synchronous and asynchronous together. You see, Q0 and Q2 are synchronous, Q1 is asynchronous. This is important. Good observation. So last half an hour before end of the class, be active. Okay. So will you try what is the modulus of the counter? You want to try? Okay, give a try. I will conduct the poll. Just I will wait for 2 minutes. You try. Meanwhile, yes, you try. I will conduct the poll. Okay, first try to find the mod. You don't see what I am doing. Find the modulus of the counter is your job. If you are ready, just give me one thumbs up. I will start the poll. I will give you the options. Only find the modulus of the counter. Shall I give any hint for you? See, this Q0 and Q2 will change based on the inputs. Q1 will change when Q0 changes from 1 to 0 because it is negative edge triggered connected in the toggle mode. Are you ready? Shall I start the poll? Actually, it is a conventional question. It will take little more time, but this model is important. Mod 3, 4, 5, 6. Shall we conduct the poll? Yeah, none. None will be always there. It is our friend. So start the poll. Wow, very good. Finally, you can see your leaderboard. What happened today? Only one poll. Very bad. Abhinay, Amitabh, Krunal, Mohan, Aman, Sadbhavana, Vasistha, Anuj, Abhineet, Deep. Okay, let's do the question. So let me change the theme. Okay. So what is the first point in this question? Find modulus of the count. So now let's do it. Okay. Listen here. Here, what I can say is Q0 and Q1 are Q0 and not Q1, Q2 are connected in synchronous mode. So Q1 is in asynchronous mode. That is when Q0 changes from 1 to 0, Q1 toggles because negative edge triggering. You accepted this? Up to this clear or not? Nothing more than this. Up to this clear? Okay. So these are in the synchronous mode. Q1 is in the asynchronous mode. And here, let's do it. What is your Q0? Q0 is equal to Q2 bar. So not Q0. Let's do what we are doing here. Analysis. What is the method I told for analysis? Same table, no change. Present state. Okay. Your input according to the design. What is your J0, K0? Very good, very good. J1, K1. And what will be the next state? Okay. So, what is your J0, Q2 bar? What is your J0, Q2 bar? K0 is 1. Okay, not J1. I'm sorry. Not J1. J2, K2. Okay. First to write, let me write J2, K2 first. Yes, sir. 1 minute. J2, K2, J0, K0. Okay. What are your J2, K2? J2, K2 are K2 is 1, J2 is Q1, Q0. This is Q1, Q0. Correct or not? What is J0? What is J0 is Q2 bar. J0 is 1. Okay. This is the first table you should make. This is Q1, Q0. This is your Q1, sorry, Q2, Q0. 1 minute. This is your Q2, Q1, Q0. This is the next state of Q2, Q1, Q0. I didn't take J1, K1 because it is fixed. What is J1, K1? It is equal to 1. Okay. So now you start with all zeros. Here assume initial exam. I will give this general. And what is Q1 into Q0? 0. What is this? 1. What is Q2 bar? 1, 1. So what is the answer here? Just JK flip-flop truth table you should know. Nothing more than that. So 0, 1 will give you output may 0. Okay, here 1, 1 will give you output may toggle. Toggle of previous value. What is the previous value? Now you tell me, sorry. Now you tell me, it changed from 0 to 1 or 1 to 0? Because I told here, when Q0 changes from 1 to 0, Q1 toggles because of negative edge triggering. It changed from 0 to 1, it will not toggle. It is same as the previous value. It will be same as its previous value. It is not changing. So if you have present state 0, next state is 0, 0, 1. So here Q1 into Q0 is again 0. Same story I am repeating. Q2 bar is 1, 1. So 0, 1 will give you what here? 0. And 1, 1 will give you toggle. Toggle of this value will be 0. Now this you understand carefully. Q1 should be analyzed separately because it is asynchronous. It is asynchronous now. You should analyze for this Q0 changes from 1 to 0. 1 to 0 happens not toggle. Toggle previous bar. So now here again 0, 1, 0. Q1 into Q0 is 0, 1, 1, 1. Again same story. What is that? It is 0 only. This will toggle. But here, tell me, it is changed from where to where? Sorry. Q0 change it from 0 to 1, not 1 to 0, na same. So when Q0 changes from 1 to 0, it will toggle. Otherwise, you should take like that. Now see here again. Now carefully observe. What is Q1 into Q0? 1, 1. Q2 bar 1, 1. So what does it mean? Here 1, 1 means it will toggle. 1, 1 means it will toggle. And here you observe it changes from where to where? 1 to 0. So it will become previous bar. Lastly, 1, 0, 0. Now Q1 into Q0, 0, 1. Q2 bar, 0, 1. So what will you get here? Flip-flop output is 0. It changed. Is it changed from 1 to 0? No, it is the same as present and next. So no change here. Okay, you started with 0, 0. You ended with 0, 0. You are able to find it is a mod 5 counter, which is counting from 0 to 4. Is it okay? Asynchronous, very simple. Lucky asynchronous is it is same as what we have done in mod and ripple counters. When Q0 is the clock input, Q0 is the clock input to this. So when Q0 changes to 1 to 0, it toggles. When Q0 changes from 1 to 0, it toggles. Q0 changes from 1 to 0, then only toggle, otherwise same value. Okay, who is that? Lucky? Is it clear? When this changes from 1 to 0, this will toggle, otherwise same. When this changes from 1 to 0, this will toggle. Thank you. Let's move to our another friend. What is that? Unused states. Sushil, see here, you started with 0, you came back to 0. What does it mean? Here I didn't take this 4. Please understand. I started 0, I got 1. Now I took this 1 here and I got 2. I took this 2 here, I got 3. If I get some number, I am taking that number here. I took 3 here, I got 4. I took 4 here. I mean, this value will be taken here. Whatever you get here next, that should be taken here. Because you don't know now what are the states we are having. So after 4, what you got, it is 0, means it is repeating the same part again. So after this, it is going back to the starting. So it is a counting from 0 to 4 only. That's why mod 5. Yeah, by default, nothing specified in the terminology. You take Q2 as the MSP. That's all it means. Okay, that's what I'm saying now, Lucky. Next, unused states. Okay, first you don't, because in the question they don't specify what are the used and unused. Here we are only finding. Sir, once explain why Q2 of 100 toggled. Q2 of 100. It is not toggled. What is the input? Tell me. Who is that? Abhinay. What is the input? 0, 1. What is the output for 0, 1? That's all. Right. So unused states, you know, from the table, from this table, you understand what are the unused states from the present state, Q2, Q1, Q0. 3 unused states are there. Let's take all of them. What are the inputs? Anuj, we know only 0. We don't know anything. From 0, I got 1. I don't know. It cannot be any number. Then I took this 1 here. Then again, I got 2. Then I took this. Until I got back 0. So here, I know, after that analysis, I know these are what? Unused states. All unused states. So what are the inputs? J2, K2. What is J2? J2 is Q1. J2 is Q1, Q0. Your K2 is 1. What is J1? Q2 bar. K1, sorry, J0. 1. These are your inputs, and here this is next state. Q2, Q1. Okay, so now listen here. Q1, Q0 is 0, 0. Here what? 1. Because you know all of them you have taken. So here 1 fix 1. Here, here Q2 bar is 0, 0, 0, 1. So what is this? 0, 1 will give you this flip-flop output is always 0. 0, 1 will give you 0, 0, 1, 1 will give you toggle. Toggle means which toggle you should take, sir. Earlier case mein, you are taking this as here, this as here. You can take, you see, earlier case, this number are same. So you can analyze from here also or here also, nothing wrong. Both are same only, previous question. previous analysis. Now you took all the unused states directly. Okay. So whatever you get here and this may not be same. Okay. So be careful. Please understand. When you give 1, 1, toggle means toggle the present state Q2. What is the present state Q2, man? What is the present state Q2? 1. 1 toggle is 0. Now comes your best friend, that is Q1. This analysis is very important. Very important. Please listen carefully. For understanding Q1 output, what is the analysis you should do? Present Q0 and next Q0. You see, what is the answer? Tell me here. It changed from 1 to 0. 1 to 0 means previous bar. Previous bar of 0 is how much? Here also, it changed from 1 to 0. You observe. This Q0 changed from 1 to 0. Previous bar of 1. 0. So now this case may present is 0. Next also 0. No change. No change means as it is. This table you should understand properly, then your life is happy. Okay. You should take for asynchronous case, be careful. Asynchronous, Q0 is the clock input. This is the present, this is the next. When Q0 changes from 1 to 0, this fellow will toggle. When Q0 changes from 1 to 0, this fellow will toggle. Here Q0 is not changed, so this fellow will not toggle. Yes, correct, Bhargavi, because the inputs are already fixed. Now, for this question, 1 minute, whatever. Yeah. Now, for this question, you take 0, 1, 2, 3, 4. These are the used states. Okay. And now what about the unused states? If 2 occurs, if 5 occurs, next state is 2. Okay. If 6 occurs, next state is 2 only. 7 occurs, next state is 0. So this is what we call self-starting. Yes, no lock. So next, listen here. Examiner has asked you one more thing. Find the maximum rate. Find the maximum rate. Sorry if I write J1, but clock is also not common. Clock is also important. Then also you cannot judge. Clock is important. Thank you, Deep. So please listen. Second point in this, find the maximum rate at which the counter will operate satisfactorily. Maximum rate means maximum frequency. Assume propagation delay of the flip-flop and AND gates are TF and TA. Let's calculate this. In your exam, any one of them can occur as the question, not all in the single question generally. Now see here. This gate is having a delay of TA. Flip-flops are having a delay of TF, each flip-flop. Now you need to calculate. He has not given any setup time, you don't worry about it. Total delay, TD. Total delay. Please listen carefully. Okay. What is the time required for the input? That is TA. T gate, that is TA. Plus, please listen, for Q0 and Q2, once the input is ready, input may no other gate is there, apply the clock, both changes at a time. Both changes at a time. So TF. This is for synchronous part. That is Q2 and Q0. Okay. Plus, listen here. Once this changes, then it will change. That is, after this only this fellow will change. So this requires another delay. This is for which part? Asynchronous part. That is your Q. So total delay is 2 TF plus TA. So what is the maximum rate? 1 by 2 times TF plus TE. Happy? That's all. Actually, this is the original question. I modified this question according to our need. I will show you the original question. This is a 5-mark question given in one of the gate, I think 90s somewhere before your birth. Okay. I took this question because the concept is nice. Actually, in the question, they have already given the mod. I have removed this part. I took the screenshot, that's why, from this part. Okay, so that you are able to find it. Udit, next state of Q1 is purely depends on Q0 only. I gave this line here itself. Q1 changes on Q0 only. When Q0 changes from 1 to 0, this is the only time your Q1 changes. Okay, so that's why Q0 you see, Q0 0 to 1, no change. Q0 changes from 1 to 0, it will change. Q0 0 to 1, no change. 1 to 0, it will change. Previously 1, it becomes 0. Q0 changes from 0 to 0, no change. Keep it as it is. Okay. Right. So let's move further. Okay. Earlier gate में conventional questions. This is gate question only. 5-mark conventional question. Earlier conventional questions also there before 2000. Thank you, people. So in ES also you can expect conventional questions like this. So let me in 2 minutes, let me give you a small concept, then we can end the class. Toggle took place for negative edge only with it because it is a negative edge triggering. It is negative edge triggering, it will toggle for 1 to 0. Follow the class completely. Some deviation is there, you cannot understand. It is written clearly here. Okay. Negative edge triggering, I bubbled this and I showed this as 1 to 0. Maximum rate is nothing but maximum frequency. Your time period should be greater than 2TF plus TA. So frequency should be less than 1 by 2TF plus TA. That's all. That is the maximum rate. No problem. Okay. So let me draw one figure for you. You can happily enjoy your weekend, just 2 minutes, not more than that. Tomorrow, I mean next class, we do complete problems on these sequential circuits. We already done more problems. We do few more number of completely problems, nothing else. In one next class, I will start state machines after doing the problems. Okay. Listen. So 1 minute, please. Individual doubts you have, just wait for some time. Let me clear this part, then remaining people will leave. Aditya, you can add that slide again after the end of the class. I will check it. There is nothing much to discuss in this, but it is what we call serial or sequential adder. In the combinational circuit, we have discussed a parallel adder. Now, similarly, this is a serial or sequential adder. It is very simple to understand how it will do its job. First, you apply the first clock pulse. Initially, assume this is 0. A0 and B0 will come. So, these two will be generally piezo or CISO. This is a SIPO or PIPO. Okay. So here input is loaded parallelly, whatever may be. Once you apply the clock, here A0 and B0 will come. Adder does not require any clock. It will give you sum and carry. Now, this sum, once you apply the next clock, this sum will be loaded. Until that, you should not give this carry back and you should not add the numbers. So now you see what is the advantage of this D flip-flop. When this input is ready here, but clock is not there, it will not allow it to be here. If you directly connect, what is the problem? This C1 will add again back to A0 and B0. So when you apply the next clock pulse, so what happens? Here A1 will come, here B1 will come, this is C1 will come. Then these three will be added, you will be getting the sum and the carry. So like that, every clock pulse may, this carry will be giving and A2, B2 will come, sum and carry, sum and carry. Lastly, everything will be stored in the register here. So here it is in synchronism with all clocks. You understand here, this is used to delay. What is the use of this D flip-flop in this case? To delay. Because C1 or C2, whatever, A0, B0 is added, you got sum and carry. That carry is to be added not in the same clock, next clock. Not for A0, B0. They must be added for next bits A1, B1. Okay. Here your output should come bit by bit because you have only one full adder. I am having only one full adder, not n number of full adders. Full adder is only one here. Yeah, this is you can say as clock is there, it is a sequential circuit. Any sequential circuit will have extra combinational part definitely, but you can say it as a sequential circuit. Here, your output should be serial. Input can be anything. Here, your input should be loaded serially. So input should be serial. Output can be anything. Okay, Bhargavi? So that's all for today and this week. So we'll meet on next Monday. Any other individual doubts, you are welcome. So remaining people, class is done. What do you do with people? Where you keep at the people? Here your bit should come serially. You cannot give all at a time. You have only one adder which will read only one bit and which will give you only one output. Where I write people, I'm sorry. SIPO or PISO, CISO. I'm sorry for that. Thank you. Thank you. Thank you. So good night. You can enjoy your weekend. We'll meet on Monday. We can discuss the more number of things. We'll do the problems. I may start the state machines also. So good night. We'll do more number of problems. I'm not loading you with the DBB today. Monday I will give you. Good night. Good night. Individual doubts, anyone having, please ask me. Aditya, you attached something, you can ask me. So just wait, all your questions will be gone. One by one you ask. First question is Abhinay. Abhinay, please, let's see. Sir, delay must be 2 TF. No, listen here. First, your AND gate, first your input is here, for example. One AND gate requires TA time. Then you applied the clock. Then it requires a TF time. So together it is a TA plus TF. After getting this, it will work and it requires another to get the final. So total another TF. All are here serial one by one events. You see, first your some value is there. AND gate requires one TA. When you apply the clock, these two flip-flops will change at a time. So TF. Once they change, this will input will go. So this will change another TF. Then you can give the next clock because your inputs are ready. First question is clear. Who is that? Okay. Wait. I will see one by one all the questions. Who is that? Abhinay is over. Next, Aditya. Anuj. Sir, last question में doubt है back side. How Q1 is taken as 1 as Q0 is not changing from 1 to 0. Where I took it is not here. It is not the matter of 1 or 0. Please listen carefully. Who is that? Anuj. It is a toggle or no toggle. JK flip flop. Please here. For example, here it is not changing from 1 to 0. That's why I took previous value. Previously, how much it is? 1. So I took 1. It is previous value or toggle we are speaking. If it is changing from 1 to 0, I told this here. It will toggle. Toggle means previous bar. Is it clear, Anuj? Here we are saying when it changes from 1 to 0, this will toggle. Toggle means not 1, previous bar. Otherwise, no change. No change is not 0. It is same as previous value. Is it clear, Anuj? What is your doubt, Aditya? What's happening? Civil engineering. So steps, please check. Where is your sheet? Again, you upload it because only half is visible. Complete picture, you take it properly. Any other? If it is, you see the figure? Examiner 0. There is Aditya took some random, right? Not there. Would will tell you 0 as used and started. Okay. It can be unused, then he will say that. That is, if 0 is the user state, what is your circuit working condition? That we are saying. You can say this counter as even in this particular case, if there is no lockout, even you start from anywhere, you get the answer. Okay, but if there is a lockout, then you suppose for 5, 6, 7 there is a lockout. Then if you start from 5, you may say it as a mod 3. Okay, if you start from 0, you may say it as a mod 5. Both answers are possible. So then generally examiner will say you the initial state. If lockout is there, if no lockout, any state you start, answer will be same. Okay. So that's all for today. We'll meet tomorrow, Monday.